Hello, my Math 150 students. Let's take a look at another rational expressions graph tonight. We're going to start off by following the same steps that we've been doing in the last couple. So the first thing we're going to want to do is factor this problem completely. This example, the numerator is already as factored as it can go. So we're going to leave 4x squared up there. But the bottom we're going to rewrite as 2 minus x and 2 plus x using a difference of squares. So just starting from there and going through the steps, we're going to start with the domain. And like always, to find the domain, we want to find where does the denominator equal 0? Well, our denominator is factored as 2 minus x and 2 plus x. So we're going to get undefined values when x equals 2 from the first factor and x equals negative 2 from the second factor. So I'm going to go ahead and I'm just going to mark those on our graph. We're going to have 2 and negative 2 playing a role. We're going to find out a little bit if they're vertical asymptotes or holes, but for now we know they're going to be undefined at those two values. The next step is to find the x-intercepts, and when looking for the x-intercepts, that means setting the function equal to 0. Uh, any fraction will only equal 0 if the numerator equals 0. So we're going to end up with x equals 0 for this one. So the x-intercept and the y-intercept end up being the same place. They're the origin. So when we find the y-intercept, we're actually going to find the same value because we're at 0, 0 in that one. So if you plug in 0 for this function, you'll get 0 out as well. So there's your x-intercepts and your y-intercepts. Let's now take a look and figure out if we have a vertical asymptote or a hole at those undefines. The way you find that out, as always, is you plug into the simplified version of this expression. Um, this one, nothing cancels in this particular expression, so a simplified version is the one that's up here. You can use either of these two expressions to plug into. I'm going to use for x equals negative 2 at first to find out if this is a hole or a vertical asymptote. We're going to get that this is 4 times negative 2 squared over 4 minus negative 2 squared. That's going to end up being 16 over 0. Anytime you get a non-zero number over 0, we have a vertical asymptote. So x equals negative 2 is a vertical asymptote. We're going to do the exact same thing for x equals positive 2. And we're going to get a very similar result because we're squaring. So it doesn't matter if we plug in a positive 2 or a negative 2, we're going to end up with the same thing. So we're going to see 16 over 0 here as well. That means that x equals 2 is also a vertical asymptote. So we're going to go ahead and we're going to put those two in as vertical asymptotes on our graph. Dotted line at x equals negative 2, dotted line at x equals positive 2. Okay. The next step we're going to do is we're going to take a look at the horizontal asymptotes in this one. To find the horizontal asymptotes, we want to see what happens as x goes to infinity. So we've got 4x squared over 4 minus x squared. We're going to do this as x goes to infinity. We're also going to do it as x goes to negative infinity. Keep in mind on these examples, we are looking to find out what the significant terms are doing. Now, what we've got in this situation, again, is a exponent or degree of the numerator is equal to the degree of the denominator. And that means our answer is going to end up being the ratio of those coefficients of those leading terms. So on the top, it's 4x squared. On the bottom, it's negative x squared. That is going to turn into just having negative 4. Okay, so y equals negative 4 is going to be the vertical asymptote as we go to the right because we're going to positive infinity. And now as we go to the left, we're going to actually do the exact same thing. It's very rare in a rational function where the left horizontal asymptote and the right horizontal asymptote don't agree. It's going to be a case where we get to exponential functions where that can happen usually. So no surprise here. We're going to get y equals negative 4 on the other side as well. So we're going to come up here and we're going to put that asymptote in at negative 4. So we're going to have a horizontal asymptote going across just like this. Okay. So the last thing we want to do now is we want to make a trichotomy number line, and we want to find out whether or not we are above the axis or below the axis. So for this one, we're going to go and make a trichotomy number line for, let's see here, 4x squared over the 2 minus x, 2 plus x. So when we do this trichotomy number line, we're going to have our 0 at 0. We're going to throw in our undefined values because the zeros and the undefined always end up on the number line. So again, always remember, put your zeros and your domain problems on your number line. And now we're just going to test values. So I'm going to choose negative 10 over here. The numerator is always going to be positive. We're squaring. So we can basically ignore the numerator in the trichotomy number line. It's not going to add any negatives. So that's always going to be positive. From here, we're going to go to the denominator. We're going to plug in that -10 value from over here. 2 minus -10 is going to be positive, but 2 plus -10 is going to be negative. That means we're going to be below the axis in this first region, okay? Negative value there. So now we're going to we're going to choose -1 from this region. Again, numerator is always positive. 2 minus -1 is going to be positive. 2 plus -1 is going to be positive. So we have a triple positive there. This guy stays positive. We're now going to move into this region here, and I'll choose 1 in this region. So plugging in 1, this value here is going to be positive. This value will be positive, 2 minus 1, and this value will be positive. So all three values are going to be positive in this case. Now that should make sense because if we go back and think about the multiplicity of this answer, I know I didn't mention it, but it was x squared equaling 0 in the numerator. Multiplicity of 2, a repeated factor. So we're going to have a bounce in that situation. And then last but not least, we're going to go over in this interval here, and we're going to choose something like 100 or any number greater than 2 will work. I'll choose 100. Top is always positive. 2 minus 100 will be negative. 2 plus 100 will be positive. That's 1 negative overall, so that's negative. So what I want to do now is I just want to take this idea with me up above. So I'm just going to copy that. I want to bring it up here, and I'm just going to paste it. So I'll have it ready. Actually, let me paste it like this so I can actually make it a little smaller. So let me paste it just to remind us what we've got. Okay. So according to this number line, we are below the axis in the first region, but we have to use this and this as an asymptote. Well, it would be impossible for me to come this way because part of it would be above. I've got to come from below. So I'm going to extend my asymptote a little bit down there, and I'm just going to draw this graph using those two asymptotes staying below. So it's going to look something like that. Okay, so now we go into the next region, and we're going to be positive, and we're going to hit this intercept right here. So we've got to use this asymptote and come down like that. That's the only way for this to look. On the other side, again, we're positive, so we're going to have to go back up like this and use the asymptote on the other side. So we're going to have a graph that goes up like this. And I should draw that just a little more symmetrical. Okay, and then the last region, we're below again. All right, my two choices are coming like this or like this. I can't come from above because I have an x-intercept, and there are no x-intercepts for this one. So I've got to come from below. So again, I'm just going to extend that asymptote a little bit this way, and then I'm going to draw the graph using those two asymptotes just like this. So in this particular function, what we've got is two vertical asymptotes, one horizontal asymptote, no holes. I hope you're able to follow along on this one. If you have any questions at all, please feel free to reach out to me. I'll be posting another example of rational functions tomorrow. Hope everybody has a great night.